Hi guys, welcome back to the third part. So let's see the problem statement. So in this we'll be using PCA and Gaussian naive-based Gaussian model. So basically we'll be trying to reduce the features, whatever is required, whatever is present, we'll be trying to reduce that, and then we'll train and test the data set. We'll test the model. So here are the steps given. That is basically we will be loading the data set. We'll be trying to encode the target variable using label encoding. We'll apply PCA to reduce the dimensionality, and then we'll be normalizing features using min-max scaler, and then we'll be applying Gaussian naive-based model. We'll be splitting the data set, and then we'll be training for original data set and PCA reduced data set. So that is this. So let's see the code. So we'll as usual we'll import things, and now we have a function called load iris data. So again, as usual, we'll be loading the iris data set as a data frame from the pandas. So then we have taken it into df for our convenience, into a variable called df, and then we're returning df. So this is the first part, that is load iris data set. Now we'll be seeing encoding target. So that is basically we'll be using label encoder to encode the categorical column called target. So because this contains all the names of the species, so that is categorical. So we'll have to convert that. So for that we'll be using label encoding, and then we'll have to normalize features. So now to normalize, we'll first drop the target column from the x, because x is for input, so we don't need target column for input. So we'll drop x, and then we'll be using min-max scaler, and then we'll scale the values of x, whatever is there now. We'll try to bring it between 0 to 1. So then we'll return scale value and target separately. So now we'll try to apply PCA, that's principal component analysis. So here basically we'll be using variance ratio 0.95. That is basically we'll try to retain 95% of the important features, but still reduce the data. So here we are applying PCA, and we'll try to fit the PCA, and we'll take a separate variable called xPCA. We'll have a separate thing xPCA, that is after applying PCA for x. So okay, so this split data we'll give all x and y as input, and test size is 0.2 with random set is 42. So test size is 0.2, that is basically 80% of the data set is used for training, and remaining 20 is used for testing. So here we'll have stratify y again, basically all the 0 and 1, or the positive and negative features, or anything which is there in the output, that will be split into that will be split equally. So anything that is there in the data set, that is split equally between while testing and training. So then this was splitting the data. Now we'll train the naive-based Gaussian model. Okay, so here we have the classifier model as Gaussian NB, and then we'll fit both x-train and y-train into NB. That is naive-based model, and then we'll be evaluating the model. Okay, so for evaluation, we'll be trying to get the value of y predicted, and then we'll be trying to get the accuracy. So this is the only two steps we are doing. First is we'll be trying to get the y predicted value, and then we'll be trying to get the accuracy of the y predicted value. So now we'll have a classification report, that is basically the output is stored in the form of dictionary. So then we have to train and evaluate PCA versus original. So basically we'll have to evaluate on original data set first, and then on PCA data set. We'll be applying the splitting data set on normal original data set, and then on PCA. So here we're applying on original, and then we're applying on PCA. So then the classifier original model classifier will be applying Gaussian NB for original, and then we'll be applying the same for PCA. Now we'll be evaluating the model for original data set, and then we'll be evaluating the model for PCA, and then we'll be returning original PCA, original prediction, PCA prediction, n features original, n features PCA. So all these things will be returning. So basically you can see output should be like this. So now we have the main function where we'll be executing all the things. So let me run this once. Okay, so original features was 4, PCA reduced features was 2. Now original data, the naive-based accuracy was 0.96 and PCA 0.9. So that's it for this video. I'll just submit this program once. So yeah, all the test cases have been passed. So that's it for this video. I'll see you in the next video. Thank you.